These are the subtractive primaries, cyan, magenta, and yellow, and I have them combined using the normal blend mode. If I take them and set them to multiply, which is a good way to simulate subtractive color mixing, we'll see that first of all they turn black. The reason is that they're on a black background, and anything times black is black itself. Well, I've set up a curves layer that lets me change the brightness of this background, and I'm going to set the background to white. Now I can set that to multiply, that to multiply, and that to multiply, and when I combine them you can see that the common color between these two is blue, so blue survives the mix. The common color is green between these two, so green survives the mix. The common color is red between these two, so red survives the mix, and if you put them all together you get black in the center. Now, since it's called subtractive color mixing, I thought I would just take a look and see what happens if we use some of the more subtraction-oriented blend modes. For example, what if we set it to difference? And we set this to difference, and we set this to difference as well. Something interesting happens. First of all, they seem to have turned into RGB. Well, if you look at the black background, or the white background at this point, let's make it black. Let's make it gray. They vanish. Now let's keep going, and let's make it black. They come back again, CMYK. So that's kind of an interesting thing right there. When we mix these two, we get the third color. So in this case, blue. In this case, the third color is green. In this case, the third color is red. Put them all together, and you get white. If we go with a gray background, you can see that we would see nothing. If we go with a black background, we still get the missing color, the missing color, the missing color, and if we mix them all, we get black. Now, what if we, instead of using difference, we try exclusion, exclusion, exclusion? Well, the interesting thing is in this particular case, the behavior is the same as difference. At gray, it starts to disappear, it goes away, and at white, it turns into that RGB. Now, because of this unusual color mixing, I would expect that if we tried it with a full color, 3-color image, that it would be a fiasco and not work at all, and that multiply would be the blend mode that only works. But let's actually try it with an image and see what happens. Okay, I'm going to take another look at these color seps and different blend modes. So the first thing is these are normal color seps. They just block each other. And I'm going to make the blend mode multiply, multiply, and multiply, because that's the best way to simulate what's called subtractive color mixing with filters. So this has green and blue, this has red and blue, this has red and green, as you can see from the white dots over the letters. Put them together, that has blue in common. Put them together, red survives the mix. Put these together, green survives the mix. And put them all together, and nothing survives the mix in terms of bright colors, and they mix to black. This operation is taking place on a white background because this is the multiply blend mode. If I were to take this background and darken it to middle gray, everything gets darker, and if I darken it all the way down to black, everything gets black, because black times anything is black. So when you're doing subtractive color mixing with the multiply blend mode, you need to do it on a black background. Now I'm going to try some of these blend modes that have more of a subtractive orientation to them, like for example the difference blend mode and the exclusion blend mode. So that's coming up next. Okay, we looked at the multiply blend mode, and we noticed that it had to occur on a white background, and I forgot to mention that notice that these are positive looking images with lights being light, the bridge of the nose being light, and the colored areas being representing dark areas, and they stay positive and they stay positive during the mix, as you would expect. Why would it be any other way? So let's try some of these other blend modes. Let's try difference. Let's try difference here, and let's try difference here. Okay, well, the first thing we notice is that everything became negative. So let's see what happens when we mix it. Interesting, it's become red, and it's become positive. And the third one makes it negative again. So let's try making the background black instead of white. We take the background darker, darker, middle gray, still darker, still darker. Now we're all the way down to black. And it's become 3 positives, and they're CMYK positives now. If we mix magenta and yellow, we get that missing color, the cyan, and it's a negative. And this negative cyan and this positive cyan are going to somehow form a proper image. How could that be? And yet, that's what happens. The missing color is magenta, and these combine to make it. It's a negative version. The positive fits in to make a full color. And the missing one is cyan, the missing one is yellow. A negative yellow, positive yellow combines to make a full color image again. So it's kind of surprising. How about exclusion, and exclusion? Well, interestingly enough, in this particular instance, their behavior is identical. And if we make the background middle gray, they vanish. And if we keep going to white, they turn into negative. So this is a little different because middle gray made it vanish, but combining them turns into a red positive, and you get a full negative when they're all put together. So that's not quite what you want. Although if I were to take all of that, and then invert everything with invert at the top, it works again. Kind of interesting. Of course, we're just back to having done it on a black background. Anyway, I expected the subtractive blend modes to not work at all because they do such an unusual thing when they mix. They make that third missing color, but surprisingly, in the case of images, where a lot of the colors in the channels are independent from each other anyway, they seem to work out. It's kind of unusual and an avenue for some interesting color correction, I think, or interesting special effects.